Hello everyone, welcome to Hydropower. Today we'll solve a numerical problem related to turbine. So the given question is, a hydropower development is to operate at a discharge of 40 meter cube per second. Normal tail water elevation is 1054 meter. Normal head water elevation is 1083.2 meter. Maximum water temperature is 70 degree Fahrenheit, at which vapor pressure is 0.25 meter. Atmospheric pressure is given, elevation is 9.26 meter. Find suitable bottom line elevation of the turbine runner where the turbine has overall efficiency of 90%. So let's start the question with solution, where the given discharge Q equals 40 meter cube per second, and then normal headwater level equals 1082.30. Normal tailwater level equals 1054 meter. So the head is 1082.3 minus 1054 equals 28.3 meter. The given vapor pressure is pressure H equals 0.25 meter, and the overall efficiency equals 90%. Equals what? By the question, the given H 28.3 is less than 30 meter, so we will use the Copland turbine, as because of the head is less than 30 meter. So now calculate P equals gamma rho Q H equals efficiency is 0.9. Placing the value of all this to 10 into 28.3 equals, the given discharge is 40. On solving this, we'll get the result is 9994.428 kilowatt. Let us consider this value into horsepower. 9994.428 is divided by 0.746 equals 13397.356 horsepower. After this, we will calculate the specific speed. The specific speed for Copland turbine NS equals 1475 is divided by H power 1 by 3 equals, placing the value of H is 28.3 power 1 by 3. On solving this, we will get 484.01 RPM is similar to 484 RPM. After this, we will calculate the synchronous speed. Now speed N equals NS H power 5 by 4 is divided by root over P equals, the value of NS is already calculated as 484 times of the value of H is 28.03 power 5 by 4, and root over P means the value of P is already calculated in horsepower, 13397.5356 56356. On solving this, the value will be 272.94 rp as rotation per second. Now let's calculate the number of pole where NP equals 120 F is divided by P, where F equals 50 Hz equals frequency of generator equals 120 into 50 is divided by the value of N is already calculated, 272.94. On solving this, 21.983 is nearly equals to 22 numbers. Now the corrected N is equal to 120. F is divided by P equals 20 into 50 is divided by, now placing the NP equals 22, the recently calculated value equals 272.727 rpm. Again the corrected as specific speed. Speed ns equals n root over p is divided by h power 5 by 4 equals, the value of n is already corrected value is 272.727 into root over p. P is in HP 13397.356 is divided by the value of H height is 28.35 by 4. On solving this, corrected NS equals 483.63 rpm. Now the diameter of turbine D equals 84.605 root over H is divided by N, where the value of phi equals 0.0242 ns power 2 by 3 for coupling turbine. For coupling turbine, so phi equals 0.0242 into ns is 483.63 equals 1.491. Now placing the value of phi in the formula for calculating D. So D equals 84.60 into 1.491 times of root over the value of H is 28.3 is divided by the value of N is 272.73. On calculating this, 2.4604 is nearly equals to 2.5 meter. So the final answer is 2.58 meter. So the bottom elevation of the turbine runner is 2.5 meter. So for today we complete the question for this much. We'll come again with another new video. Till then, keep on watching our channel and don't forget to subscribe us, like and comment on our channel. Thank you.